Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the next question, question number 22 of Physics Paper 2, 2017 JEE Advanced Physics Paper. So let us solve the question number 22. Students, let us solve the next question, which is question number 22. It is from magnetic effect of electric current. A symmetric star-shaped conducting wire. It is a star-shaped conducting wire having how many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. So we figure the distance between the diametrically opposite vertices. This is one vertex, another vertex. This is diametrically opposite vertices of the star is 4a. So this distance is 4a, this distance is 4a, this distance is 4a, opposite vertices diameter distance is 4a. So obviously then this will be half of that, this will be half of that, this is a, this is a, this is a, this is a, 4a. The magnitude of the magnetic field at the center of the loop. So at this point, this is the center of the loop. What is the magnitude of magnetic field? The magnitude of the magnetic field will be due to the contribution from all those conductors, 12 conductors. First of all, you can see that this goes down, this goes like that, this way, that way, this way, current will flow in this way. If current flows like that, if you talk about any conductor, suppose I am talking about this conductor, this one, this conductor, like this, current is like that. If I hold the conductor, then the magnetic field will be in this side, it will be up. For this conductor, up. For that conductor, up. You can see the current is like that. If I hold it like this, then this side. For any conductor.
सर आप जो दिखा रहे हैं ना वो कैमरे में दिख रहा नहीं, थोड़ा ऊपर लेना पड़ेगा। क्या इतना ही आता है ना?
बंद कर
चलो स्टार्ट.
Okay, now the conductor, if I talk about this conductor which is in this side, the current is from this side to this side. Then if I hold the conductor like this, the magnetic field this side will be upward. Similarly, if I move the conductor like this, which represents this conductor like this, then also magnetic field will be in this side. Then the conductor like this, then also it will be this side. So the contribution of magnetic field due to all those conductors will be this side only, and they will add up. Whether their magnitude is same or not, that will check out, but their contribution is obviously going to add because the direction is same. So what we'll do is that we'll consider any one side and any one conductor out of these 12 conductors and try to find the magnetic field contribution due to each of these conductor. Now this way I'm just drawing this part only. Suppose the center is over here. I'm trying to analyze the thing about this point. I'm drawing only this part over here. The current is like that. I want the contribution by the any one part of the conductor, this one. Then if I complete this, what is the contribution of this part of the conductor at this point, magnetic field? Then I will suppose I consider this one, it is better to work out. This is the line, this is the perpendicular line drawn from here to this extended line, this line. This is perpendicular distance. So this part of the conductor, if I join this to this point and this to this point, then this part of the conductor, what angle it makes? This top part from this line, this makes an angle, suppose theta 1, and this part from this line makes an angle, suppose theta 2. This is theta 1 and this is theta 2. Okay, this angle is theta 2. This is the angle between the part that is the lowermost part and this line. Which is this line? This line is the shortest distance, the distance which is perpendicular to this extended line. Similarly, this is theta 1. We know that if we have a conductor like this and at a distance say d, current is like that, at a distance d, suppose that this part projects an angle theta 1 and this part projects an angle theta 2, then the magnetic field at this point, if the current is I, then the magnetic field is given by mu naught upon 4 pi I divided by this distance and sine of theta 1 plus sine of theta 2. This is the formula you are going to use. If this is the formula you are going to use, and we must take note that this formula is derived when this is the shortest distance, or this is the distance d which is perpendicular to this, and this angle lies below this side. So these two angles lie on two opposite sides of this line. This side it is plus and this side it is minus. If this is we have taken plus, but if this angle also lies to this side, then we'll take minus. So what I have to say is, this wire and this wire is no different. Now the point is not here, just like this, the point is somewhere here. If the point is here, not like this, suppose I have a point which is suppose here, if I would have taken a point here, then with respect to this line and that line, it would have been, what I am to say is, if I have a conductor like this and just like the previous one, but I am not taking a point over here, I am taking a point over here. If I take a point over here and I want to find B, then what formula we will have? Then what formula I will have? You can see that instead of this, I will have a certain changes, because this line I will join here, from this part, top part, I will join to this point. Now this extended line is here and this is the perpendicular distance. This is the perpendicular distance. Now this part, this perpendicular distance, for this part this is theta 1 as usual this is theta 1, but this theta 2 is lying above this, the same side of this theta 1. It should have been this side, because it is on the same side, we will consider this as negative, because our angle is actually this angle I have to take, because theta 2 goes below this. We have to find theta 2 below this. So this one is the angle theta 2, but here theta 2 is up. So either you take this one, this angle, or you take negative of this angle. So this will become negative. So for this case, so here it will be negative, because this is in the same sense as this. So for here, for this situation, if the current is I, the distance still remains d, then mu 0 upon 4 pi I over d sine of theta 1 is no problem, but theta 2 it will become negative. It is minus sine theta 2, and sine is a odd function, so it will become theta 2 negative. This is the situation, and exactly this situation is considered here. This is a line. If I just draw this line to just this line, this is the line, okay, and the point is somewhere here. The point is extended, this point is somewhere here. Now this one and this one, from this line, this top part is okay. This top part is, this angle is from here to top part. Here it is theta 1, no problem with that. But this part is theta 2, which is negative. So therefore we'll use this equation. So for this line, I'll use the equation b equals to this one, mu 0 upon 4 pi I by d. What is d? This d is this distance that I have to find. What is this distance? The total distance is 4a. So from here to here, it is 2a. But our distance is only this one. This one is, because this is the angle it is projecting, and I am interested in this distance. This distance is a only. So here this distance is a. If this is a, I'll write a here. Sine of theta 1 minus sine of theta 2. Now our aim is to find theta 1 and theta 2 and substitute here. What is theta 1 and theta 2 from this triangle? Because it is, if I just complete that, this will be equilateral triangle. This is A, 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 this one. So I'll just let me find the, if I complete that, this one and this one, then this is 90. Obviously this is 90. What is this angle? This is regular 12 sides. So if it is 12 sides, then each side will project an angle. What angle at the center? At the center, each side will project certain angle at the center here. What angle it will project? Let me find out that. For a regular this 12-sided polygon, the angle will be, by any side that will project, is 2 pi divided by n number of sides 12, so it is pi by 6. So each side will project an angle pi by 6. So pi by 6 is 30 degree. So this angle is actually 30 degree. Each side will project an angle 30 degree. This is 30, and this is 30. Then what about this angle? This angle also you have to find. Now this angle is 30, and what about this angle? This angle, this is 90. This is this should be 30. So this should be, this angle is also 30. This angle is also 30. This is 30. This is angle is 30. So from here to here, this angle is 60. So what I have to say is that this angle is 60 and this angle is 30. The total angle here is 60 and this angle is 30. So that means theta 2 I'll put 30 and theta 1 I'll put 60 over here. Let me first put this and get the answer, then I'll come back to this how to find that angle. So if I put that here, what I'll get, B, due to a single part of the conductor, the magnetic field contribution will be mu naught upon 4 pi I upon A sine of theta 1, which is 60, minus sine of 30. Now putting the value of sine 60 and sine 30, we will get the expression mu naught upon 4 pi I over A. Sine 60 is root 3 divided by 2 minus sine 30 is half. This 2 goes out, and okay, let me put this way. This 2 goes out, and this is mu 0 upon 4 pi I divided by 2A and root 3 minus 1. But how many such sides are there? There are 12 sides. Similarly, the contribution of this conductor at this point will be symmetrical, so it will be same. So this 2 is over. Now if I think of, just I'll rotate this, just if I think of this line and this line also projects at the same angle, same magnetic field here. So therefore this also at this point will have the same contribution. So each side will have same contribution. So that means there are 12 sides because of 12 sides. B net will be obviously pointing upward out of the plane of the paper, and B net will be 12 times B individual, which is 12 times this value, that is mu naught over 4 pi I over 2A root 3 minus 1. This 2 cancels, then becomes 6. So it becomes 6 mu naught over 4 pi I over A root 3 minus 1. So if I see the option, then mu naught I upon 4 pi A, this is there, only 6 is taken inside, this is brought here. If this is brought there, then this can be written as mu naught upon 4 pi I over A 6 of root 3 minus 1. This comes out to be like that, and this is option number 1 is correct. Mu naught of I upon 4 pi A 6 times root 3 minus 1. So therefore this option is correct. So this is how this question is solved, but then you must know how to find the angle, because this always subtends an angle of 30 degree because it is 12 sided. This is 30 degree, so this also will project an angle here at this point 30 degree. So this angle is also 30 degree. This is 30 and this also projects 30, so it is 60. 30 plus 30 60. So from this line, baseline, this point projects an angle of 60 degree and this point projects an angle of 30 degree. So theta 2 will be minus 30 and theta 1 should be plus 60. So that putting that will get the answer. Okay, thank you.